Okay, hi all. Today we're going to move on to a new section, even though it is something that you may have done a little bit in the past in first year or even in primary school, and it's called Patterns and Sequences. And in your book, I think it might be called Patterns and Relationships. So it is all about relationships between numbers, and there are some similarities to this topic and functions as well that you'll see as you go along. But in my experience, students tend to prefer this topic to functions. So, for today, what we're going to look at is number sequences and the pattern in which those numbers go in. There are other types of patterns and sequences, like sequences of images and patterns with colors and that type of thing that we'll be looking at later on. But for today, it's just going to be number sequences. So, if we look at, I've just put an example of 4 different number sequences here, and you might be used to these from primary school, where you have the first few numbers in the sequence, and then this 3 dots here means that the sequence keeps going on forever after that. And usually the question is, what's the next number in the sequence? So with this one, 2, 4, 6, 8, I think we can all see that the next number is going to be 10. Okay. For this one, it's 1, 4, 9, 16. Not as easy, I would say, but we might recognize a similarity or something that all of these numbers have in common, and that is that they're all square numbers. You know, like 1 is the square of 1, isn't it? 1 squared gives you 1, 2 squared gives you 4, 3 squared gives you 9, 4 squared gives you 16. So your next number in the pattern is going to be 5 squared, which is 25. Okay, this one over here, 21, 18, 15, 12. And again, we're starting at 21 and we're going down this time, down by 3, down by 3, down by 3. So the next number in the pattern is going to be 12 minus 3 is 9, isn't it? So then lastly, we have this one here, 1, 2, 4, 8, 16. And what's the next one? It's going to be 32, isn't it? So what we see happening here is you start with 1 and then you double it and you double it and you double it and you double it, etc., etc. Okay, so there are lots of different types of number patterns, but today we're just going to concentrate on one particular type, and it's called a linear pattern or a linear sequence. So linear sequence. And a linear sequence has a particular quality, and we have a way in maths of showing that a sequence of numbers is a linear sequence. Now, there are 2 linear sequences from this example of 4 up here, and it's this one and this one. They're both linear sequences. And linear sequences are basically sequences that go up or down by a set number each time to get from one number to the next. So for instance, in this one, we have 2 to 4, it's going plus 2, isn't it? It's going up by 2. 4 to 6, it's going up by 2. 6 to 8, it's going up by 2. Okay? Over here, we can see 21 to 18, it's going down by 3, isn't it? So minus 3, minus 3, minus 3. Okay? So both of these are linear sequences. These 2 here, linear sequences. Over here, if we were to test to see if these were, and this is a test for a linear sequence, we could just go like this. 1 to 4 is plus 3, isn't it? 4 to 9 is plus 5. Immediately, we can say, without going any further, this is definitely not a linear sequence. So it has failed our test. These 2 over here, I mean, if we kept going, we'd see it was 2, 2, 2, and this is minus 3, minus 3, minus 3. Those are linear sequences. We'll test the last one. 1 to 2, that's going up by 1. 2 to 4, that's going up by 2. I don't need to go any further, you know, plus 1, plus 2. That's definitely not linear. The minute one of these is different, then you know it's not a linear sequence. So if I just not linear sequence. Okay, so that's the first thing. The next thing, I suppose, just a little bit of notation. This here whatever this that we calculate, we call it the first difference. First difference. Okay, so we could say the first difference is the same all along here. The first difference is the same all along here. Therefore, they are linear sequences. We could say here that the first difference is not constant. That's not the word we use for the same. And here, the first difference is not constant. Therefore, they're not linear sequences. So in a question, if you were asked, is this a linear sequence or not? You could do your test, and I would do this, and I would show these numbers in exactly this way. And there, your answer would be, in this case, not linear because the first difference is not constant. In this case, it is linear because the first difference is constant. So first difference is constant. And it doesn't matter if the first difference is positive or negative. As long as it's constant, it's the same all the way through, then it's a linear sequence. Okay, so that's the first thing. Linear sequence, first difference is constant. Okay, the next thing is sometimes we want to be able to describe how you get from one term to the next in a sequence, okay? And we have what's known as a term-to-term rule. So term-to-term rule. And in this case, let's go for the term-to-term rule for this one. We could say that to get from this term, the first term in the sequence, to the second term, what do we have to do? What's the rule? It's just add 2, isn't it? And in order for it to be a rule for the entire sequence, we have to be sure that it's the same going from any term in the sequence to the next term. So for instance, getting from this term to this term, what do? You add 2 also, don't you? Getting from this term to this term, you add 2. So the term-to-term rule for this sequence up here is just add 2. Okay. Now, even though we'll be mostly dealing with linear sequences today, we could come up with a term-to-term rule for these, but we'll be waiting until we've learned more about them in the next few days. Okay, so that's your term-to-term rule. The next thing we want to talk about is coming up with a type of formula that describes these sequences. And this is where it gets, I suppose, a little bit similar to functions as well. We're looking for almost like a function to describe these excuse me, linear sequences. But we have a different language that we use for patterns and sequences. Rather than calling it a function or a formula or something like that, we have 3 different ways of describing the formula here, I suppose. And if you like, just write function / formula. We call it either. The first way is the nth term. I'll explain that in a minute. The nth term, or term n, or we call it the general term. Oops, sorry, the writing wasn't showing. So the function or formula that we could describe these linear sequences with, or these linear patterns, we call it the nth term, or term n, or the general term. Okay, so this formula, we have a way of coming up with the formula, and then we have different uses for the formula. So first of all, let's work out how we'd come up with the formula. Well, the formula is in your log tables, and I'll just get the log tables out myself to show you what page. So the formula is in your log tables, and it would be under this section which says sequences and series, page 22. So on page 22, we've got several different formulas. Now we've got arithmetic sequencer series, and then we've got geometric sequencer series. This is all leaving cert stuff. There's no need for you to look at that. This arithmetic or arithmetic sequencer series, this is the Tn formula here is what we're concerned with. Okay, the term n, that Tn stands for term n, which we saw was one of our names for that type of formula. So term n, or the nth term. So this is the formula. It's in your log table, so you don't have to learn it off by heart. There are different letters in the formula. So there's the A here, and it says A is the first term. So the first term in a sequence, for instance, in this one is just 2. In this one, the first term is 21, isn't it? So that would be the A. D is the common difference. So the common difference, the common first difference, if you like, the common difference for this one is plus 2. D would be equal to plus 2 here. In this one, D would be equal to minus 3. That's the common difference between the terms. It's a minus 3 because it's going down. Okay, so let's see if we can use this formula to find term n for, maybe we'll go for this one up here first of all. Okay, so just go down here. Right, so the formula first of all, term n is equal to a plus n minus 1 times d. Okay, that's your formula. Now let's sub in values so that we're working out the formula for this. So term n, and again, we're not going to sub in anything for the n's here. It's just the a and the d when we're trying to get the formula. And we'll see in a minute what we'll use the n for. So we said a already is the first term in the sequence. So if we're using this sequence here, the first term is 2. So it's 2 plus, again, we're not subbing anything in for n, so we have to leave that as n minus 1 for a minute. D, and d we said is the common difference, a common first difference here, plus 2, isn't it? So 2. Now be careful, it is a plus 2, as in it's a positive 2, but we don't put in plus 2 because we're multiplying by d here. Okay, so that's just subbing in the values. We can certainly tidy up a little bit then. We say Tn is equal to 2 plus, if we multiply this 2 into this brackets, well, if you pretend the 2 is on the other side, because multiplication is commutative, it doesn't matter the order you do, whether it's this multiplied by 2 or 2 multiplied by this. So 2 times n is 2n, 2 times minus 1 is minus 2. So last bit of tidying up then, Tn in this case, well, 2 take 2 is 0, you're just left with 2n. Okay, so that's your term n, or your nth term, or your general term. So let's talk a little bit about the language of what this means, term n. Well, first of all, if we go back up here, when we talk about terms, we're talking about all of the numbers in the sequence. So this is the first term, second term, third term, fourth term, if I kept going up, fifth term, sixth term, etc., etc. So term n then, or the nth term, is standing for a general, again we call it the general term, so it's like for term something or term anything is equal to 2n. If you wanted to find term anything, you'd just have to multiply the anything by 2. In other words, we could use this formula to find any of the terms in our sequence. So it was quite easy to find the fifth term, or the next term. We just added 2. 2 and 8 was 10, wasn't it, to find the next one? But if I told you in a sequence, find the 232nd one, it might not be as simple. However, if we have our formula, we can easily find any term in a sequence using this formula. So let's find the, I think I said 232nd term. And here's how we note it. We call it term 232. That's the 232nd term. Okay? Is equal to, oops. We follow the formula. We sub in 2 times n. Well, n is the position of the term. So term 232 is the 232nd one. This would be n equal to 2, n equal to 3, n equal to 1, the first term. N equal to 232 is the 232nd term. So we sub that in. And that gives us 2 times this, 464. If we wanted to know what number would be in the 232nd position of this sequence, that number would be 464. And this formula would allow us to find any term then. Okay, one more example of a question using what we've got here. We won't do anything more than that today, and we'll just see how we use all of that information that we've learned above. So this example I have down here, it gives me a sequence, -1, 4, 9, 14. And it says, for the given sequence, what type of sequence is it? Well, we'll test now. Since we only have the name of one type of sequence, it had better be a linear sequence. But we'll test it. -1 to 4 is going up by 5, isn't it? 4 to 9 is going up by 5. That's a +5. +5. So it's the same amount all the way through. So we can say linear sequence. And why? What do we say? Why is it a linear sequence? Because the first difference is constant. Okay, because the first difference is constant. What is the term-to-term rule? So in plain words, what's the term-to-term rule? It's just add 5, isn't it? Perfect. Add 5 to get from one term to the next. What is the sixth term? So when it's a low number like 6, we can just maybe, without getting any formulas or anything like that, we can say, well, 1, 2, 3, 4, I have 5 terms there. So the fifth term is the next one and the sixth is after that. So what am I doing? I'm saying going up by 5 each time. So the next term would be 14 and 5, which would be 19. And then the sixth term would be 19 and 5, which would be 24. Or else I could have gone up by 10, couldn't I, to get up 2 terms. So 24. Sixth term, 24. And I'm going to write it like this. Term 6 is equal to 24. Okay? And then second last, what's the general term? So the general term, remember, is a fancy name for the nth term or term n. So that's where we're using our formula. So we say the formula, first of all, term n is equal to, and it's in the log tables, plus n minus 1 times d. Going to be kind of short in space here, so I'm trying to keep it tight. So term n is equal to, well, a again is the first term, -1, plus n minus 1. Remember, when we're forming the formula, we don't sub in anything for n. It's only when we're using the formula to find something. Times d. D is the common difference, isn't it? In this case, 5. So term n is equal to -1 plus, now 5 times n is 5n. 5 times -1 is -5, isn't it? So tidying up a little bit, term n is equal to -1 and -5 is -6. So 5n minus 6. Okay, that's your formula. Last one then, what is the 126th term? And I just want to show you one other thing after that and we'll be finished. So term n, we use our formula. And instead of the n, we put in 126. If we're looking for the 126th term, we're looking for term 126. And again, we're subbing in. If we're putting in an n there, then we must put the same n value in there, 126. So 5 times 126 minus 6 is equal to, and I'm going to get the calculator out for this, 126 multiplied by 5 is 630, minus 6 is 624, isn't it? So equal to 624. So term 126 is equal to 624. If we went up, counted up 126 terms, that's where we get to. Okay, one last thing then before we let it go. If you had not been given this pattern at all and you were just given this term n in the first place and they asked you to write down the first 4 terms in that pattern, you could do that using this formula, couldn't you? So I'm just going to get a little bit of paper to do that. Okay. So imagine the formula, your general term here is Tn equal to 5n minus 6. Tn equal to 5n minus 6. You wanted the first four terms, so let's go one at a time. Term 1 is equal to 5 times 1 minus 6, which is equal to 5 ones are 5, take 6 is minus 1. Excuse me. Term 2 is equal to 5 times 2 minus 6. 5 twos are 10, take 6 is 4, isn't it? Term 3 is equal to 5 times 3 minus 6. 5 threes are 15, minus 6 is 9. And term 4 is equal to 5 times 4 minus 6. 5 fours are 20, minus 6 is 14. And you'll see minus 1, 4, 9, 14 is the same as minus 1, 4, 9, 14. So once you have the formula, you can generate any of the terms in the sequence.